It's my pleasure to welcome our guest, Mrs. Ezhilarasi Kesavan, to the session. Now, she is going to share her knowledge on serverless computing. And regarding her experience, she's having an experience of more than a decade in IT industry and with a knowledge spectrum that spread across various domains. And she is passionate about Microsoft Azure offerings like Logic Apps, Azure Functions, and Azure Service Bus. And she is a Microsoft certified trainer with certifications on MSCA Web Applications and MSCD App Builder. And she is an active speaker for TechMeet 360 and like to share her ideas with the community by authoring technical articles focused on Azure serverless technologies. Yes, ma'am, you can start the session. And students, if you have any questions, you can ask at the end of the session. Yes, you can type the questions in the box so that she will answer all your questions. Yes, ma'am, you can start the session.
Thank you so much. Thanks for the wonderful introduction. Yeah. Let me share my screen and then start with the presentation. So I'm so happy to address a fresh set of candidates here today on the topic Introduction to Serverless Computing. So a lot of good things. Today marks my work anniversary as well. So 11 years back, September 14th is when I stepped into my first career with Infosys as an fresh graduate from college. And time has just gone by just like that with a lot of learning across industries. I have tried my hands with training fresh graduates from college, working with projects, working on startups, and now I'm tied up with Coimbatore, a multi-product company for the past 3 years. So it has been great learning, and always the best part has been sharing my knowledge with the people who were interested on scaling up their skills. So today's topic is also very favorite and close to my heart. In the last 3 years, I have been spending my efforts and time into exploring the serverless computing space. And my current role also helps me a lot in acquiring more knowledge onto this space. And it also helps me exhibit my knowledge that I gained with the communities through community activities. So let me step into this particular topic. What is serverless computing? So let us look into decades of application development. So as I told you, it's been 10 years I have been into this industry. So I started my career in the phase when the go-to option to deploy an application was to buy your own service. So I remember in my initial days of starting my career with Infosys, if I need to host an application and make it available to anybody to use it. So we used to develop internal applications that might make things work smarter. So the option was to get my own server, put it into my cabin, deploy the application in IaaS hosted on my server, and then make it available for anybody to use it within the organization in case of intranet applications, or in case of internet, I need to make that server being available on internet, which was the classic way of building the applications. But when we look through how things have evolved, it's a drastic development. So people have been adapting to the changes in the trend of building applications. So now, no longer it is required for me to buy my own server and then make my application available to end users, isn't it? So the server physical existence of the server, even the current generation developers, you might not even know how does a server room would look like. That is how we are heading towards. But how this evolution has happened, there are key milestones that we need to understand before we understand the significance of serverless computing. So when cloud came into picture, that is, I need not have my own server physically being present in my premise. Yes. So, but what is the overhead of maintaining a server on your premise? That is also very important to understand, to appreciate the current developments in computation field. So what are all the overheads? I need to make sure that my the cable that connects my servers to the intranet or internet doesn't go off. So this is one common challenge we have always encountered when we used to manage our servers. Say the cleaning person would come in, they will pull out the cable and go, and the people accessing the application in the classrooms will not have the website loading. So this is one very minute but a very common but a very critical challenge. It might make the application itself not being available. So apart from this, updating the operating system of my server is within my scope. I need to take care that the power supply to the server is being maintained. All the security patches are installed upfront. So these are all overheads when we are looking at managing a huge application from a physical management of the server point of view. Apart from this, I need to make sure that the patches are all installed on time, and I need to make sure that the scaling of the application is met. It is completely on my scope, isn't it? I will have to procure the appropriate configuration machine and make sure that any sudden load or spike in the request has been handled by my server. So these were all lot of overheads. Along with that, I need to focus on my business logic or the actual application that I have to deliver. So then cloud came into picture, wherein these physical servers got eradicated. Like I can subscribe to an portal wherein I would find a number of infrastructures as a service. So instead of actual machines, people started adapting to virtual machines. So I do not know where exactly this particular virtual machine is located in the globe, but I can connect to it. I can work on it. I can ensure the patches are installed. I can make sure that the scaling is met. I can choose virtual machines of various configurations to get my things done. So this was infrastructure as a service phase, wherein the virtual machines were bought on cloud. The next phase brought in a vast difference. So I was tired of managing virtual machines as well. So I was looking for platforms as a service. Say all that I need is an web application to run in the virtual machine. Why should I buy the complete virtual machine? Whereas my requirement is just an managed application. So the trend started changing, wherein there were web apps, there were API apps, there were web jobs that were introduced, and there were mobile apps. So these managed services indeed changed the way we were working. So instead of buying a complete virtual machine, I started buying a web app. One clear differentiation or an advantage here is I'm just paying for the service that I am using, instead of paying for the complete mission, wherein the scope of management at my end is also wide. So this PaaS service indeed was a milestone in cloud computing. And now the current trend is, see, lucky you people are who are getting into the IT industry now, wherein serverless computing has come into picture. Wherein, see, as you observe, all these milestones are trying to reduce the overhead on people who are developing the applications. So that is ideally what serverless computing is also attempting to do. So as it says serverless, does it mean there are no servers in existence? Can that even be happening? No, isn't it? So there are servers, but I needn't worry about it. So my server upgrades or the scaling or the patches, everything is being taken care of by the service provider. So who is a service provider? Since I am associated with Microsoft, I'll help you understand serverless computing through Microsoft Azure, which is their major cloud computing platform. So serverless services in Azure are helping us achieve our business needs without worrying about the servers. So all the overheads of maintaining the server is no more my challenge. So I can just focus on the core business logic that I need to achieve by adapting to serverless computing. So it appears to be an beautiful gift, isn't it? It is indeed a wonderful gift for all those who wants to build applications Yeah. So, but this doesn't suffice me saying that just because I say that serverless computing is the next era of generating applications, you need not go ahead with that, isn't it? You need informations to substantiate this statement. So let us see. Let us try to understand a bit more about what is serverless computing. So here, as I said, the term serverless doesn't mean that the servers doesn't exist. Instead, it means the servers are completely abstracted. At the background, there are still servers running, but I need not worry about it, which means the patches on the server, the security patches, upgrades, operating system upgrades, everything is being taken care of by my service provider. So all that I have to worry about is my knowledge on the service that I am using to fulfill my business need. See, we were talking about certain terms like logic apps, function apps. So these are certain serverless services that Microsoft Azure offers. There are other services which other cloud service providers also offer, but from Microsoft Azure's point of view, they offer service bus queues and topics, logic apps, and function apps. We are going to see with much examples on how these services can help me build a real-time application. But in all these cases, I need not actually worry about the background server. See, if I want to perform an operation and problem statement, a set of business executions, I hope all of you be aware of coding. Like in the language that you are comfortable with. If you want to execute a set of instructions, all that you have to worry about is the logic that you want to build. Your code can get executed, and in a minute of time, you will get a publicly accessible URL in which the code can be accessed by any app, or it can be hosted or served to any of your customers. So that is the beauty of serverless. Instead of worrying about where is my actual server existing and how it has to be maintained, I can just focus on my core business logic. And what about scaling? So server is not within my scope. What if today morning I get just one customer request? Say I have a website, the background logic of it. Say when the moment a user comes and uploads a picture into this, I run in Photoshop. Okay, so like a landmark studio or something. So I enabled online transaction with my customers, considering the current pandemic situation where I cannot expect people to come to my store and then hand over the pictures, get it delivered. Okay, so I let people to upload a picture, and I would do further processing and deliver their order. Think of some Vistaprint or an online personalized gift store. So people would upload their picture. Some processing happens, which takes care of resizing the picture to fit into my magic cup or print it on a cushion. So these are some resizing operations that needs to be carried out as soon as a person uploads their picture into my website. Okay, imagine. So this, if you have to do it your classic way, then we will have to procure a web app. You need to write your whole code that will pick up the file, resize it, and then perform further operations. Okay, but we can use the serverless computing service like Function app, which can help you just focus on the resize logic. Okay, so if it is a cushion cover, the size should be XX cross X. If it is a magic mug, the size should be this. So all that you will have to focus on is this simple logic that will resize your image based on your product requirement. Okay, so it will let you just focus on this particular business logic. So how does scaling work? Say today, Raksha Bandhan phase comes wherein many people would start gifting their loved ones across the world with a number of personalized gifts. So for such trends, when Diwali comes in, so I expect sudden spikes. So which means till yesterday, the load on my application is going to be 1 or 2. But as soon as this season starts, I expect thousands and thousands of people all of a sudden jumping into my website. So how do I build an application that can stand such spikes? you need not worry about it. All that you have to do is choose serverless architecture. Choose an Azure function. The background, the serverless service will take care of auto scaling itself based on the incoming traffic. So all that I have to do is still focus on the 4 lines of code that I will have to write. So this is the beauty of serverless architecture. And it is event driven. So what do we mean by event driven? So when we observe even ourselves, right? So now our requirement has become more on demand. Say we no longer appreciate watching movies on the cable connection, isn't it? Because that is on the stipulated time. You will have to wait for Saturday evening 6:30 to watch a movie, which I no longer want. I just want to log into Amazon Prime, choose the movie, and then start watching it. Our customers has changed. The user base has drastically changed. So you need to build applications which are event driven. What do we mean by event driven? Let the user demand for what they want, and your application should react to it. Okay, say for example, when I go into an coffee shop or a Swiggy, for example, so I would order food when I want it. The moment I order food, I want that to be passed on to the restaurant, and the restaurant and also to the delivery person. They need to be connected and my food should get delivered. So this is an example of event driven. So the application, the Swiggy app, should react to customers' request. So how will it know that a customer has placed an order? It has to continuously listen to the repository wherein the messages would come in. So we'll see in more detail about this simple e-commerce scenario, how it can be built efficiently with the help of serverless services without much effort, in fact. Yes. And above all these, there is a very important point. Yes, say when I have my dedicated server, I was paying for the server for all the days that I have it, even if the traffic was less. So there was not even a single person visited my website. Still I have to pay because I have bought that particular service. It's the same with an IaaS. Say when you buy a virtual machine, when you hold it for a month, you get paid for that. Yes, you will have to pay for that. We won't get paid. We will have to pay for that. And when it's just a PaaS service, when I have an web app of a specific configuration, whether we get the traffic or not, I will have to pay for that particular service. And that's not the case with serverless service. So if I have a function app that is executing the backend logic of my business application, if I get one hit today, I just pay for that one hit. If I get 10,000 hits a day, it auto scales and I just pay for the 10,000 hits. So it is pay only for what you use. All the serverless services goes with this principle. You just pay for what you use. I hope everyone is with me and it is interesting, isn't it? So now comes the question, why should I choose this? Okay, so we saw what is serverless. It is going to abstract the server completely from me, and I just have to pay only for what I use, and it is auto scaling. Yeah, that's all wonderful. Then why should I choose this service? So when I choose serverless, as we discussed, so I hope you people would be aware of the concept called DevOps. So when you all start getting into the IT industry, you will no longer be called as developers or operations person. So who is a developer? Who is an operations person? A developer is somebody who will build the application. It is also required to support your customers when your application goes live. That is the operations team. It is when a customer has a problem with their application, they comes to the operations team. Operations team is expected to solve the issues. It could be an issue due to scaling or availability or security, anything. The operations team is expected to take care of it. And the good news for you all is when you start jumping into IT industry, there is no longer a segregation of a developer or an operations person. You will have to do everything. Yes, that's a DevOps person. So an engineer is expected to involve in all the phases of a software development. Right from like ideating a feature or collecting a requirement from a customer, it differs. When it is a product, ideation is a initial phase, whereas when it is a project, that is when it is a service being rendered to the customer, you will have to acquire the requirement from your customer. So right from the initial phase, you'll have to develop the feature, go through a requirement analysis, and then come up with the design of it, develop it, ship it to the production, and support your customers. This is how industries work now. So they want individuals to be equipped with all the levels of product development life cycle, which has then become need. So that is where an excellent tool set is very much necessary. That's where like tools like serverless services has to be rightly used to build real-time smart applications. And the idea here is to reduce the DevOps time, which means your development and operation should work seamlessly without much of efforts. So serverless is an excellent candidate to support such industrial transformations because this is event driven, auto scalable, and you don't worry about the servers, right? So your overhead or operations challenges are much reduced. So when they say a function is 99.99% available, it should be available. If not, it is not available. We will have to reach out to the service provider and make sure it is available. Rather, in the olden times, it is like you will have to make sure that your server is on. You will have to make sure your application is up and running, which is an overhead. Now, with serverless services, you get a reduced DevOps overhead and faster time to market. As I said, so when say for example, I am giving you a challenge to create an application. Say whatever tweet I do, I need to know immediately like what is the sentiment that I can expect from my audience. So this is an digital marketing analyzer tool and one-liner requirement. Every tweet has to be analyzed and I need to know a sentiment score of it. That is, will this be and create a good impact or a bad impact? So this is very critical when if we ask politicians, because right now digital marketing plays a key role in political decisions even, right? So when it comes an election time, every politician will have a separate digital marketing team who who dedicatedly perform on social branding for them. So in that case, it is very important to understand how does a tweet predict how does a tweet will work. I construct a tweet and I need to make sure that it creates a positive impact among my global audience so that I can proceed with publishing the tweet. So this seems to be a critical requirement. But how long do you think it would take to create an application that will tell me and score of this particular tweet? Anything that gets into my account. Anybody can come forward and then give me a prediction. Yes, Jitin. Jitin, if you don't mind, can you unmute yourself and then tell me how long do you think building an application like this will take?
Yes, ma'am. I think students will not be able to unmute because
all
the options were taken. Yes. So just they can post the answers because there will be no distractions. Yeah.
Okay, that is okay. Fine. So let me show you how long does it take with adapting to serverless applications. Okay. So let me try to create an logic app. So obviously, if I have to do it in the classic way, I will have to procure an server, I will have to brainstorm, arrive at the logic, choose the right technology, and consume the APIs. That itself is a huge learning here. In between, I was working with an digital marketing product wherein we will have to consume Facebook, Twitter APIs. That itself is a huge learning. But with serverless service like Logic App, it has been made quite simple. I hope my screen is visible wherein I'm projecting an Azure portals. Yeah, wherein you can just create an Logic app. at a matter of few minutes, and it takes care of connecting to the Twitter API, authenticating you, and then coming up with the logic. So it just, all that it takes is few minutes, and the logic app would be made publicly available in a matter of few minutes. Let me choose another subscription. Twitter Analyzer. All that I do is just give a name, choose a region, and then review and then create. So Logic App is one of the best services to start off with learning serverless computing, because it itself has hundreds of connectors readily available. So the one I just mentioned as Twitter API is just one example. If you want to send email, you have a connector already available. And when a tweet is getting posted, I want to analyze its sentiment score. There is an API available called Cognitive Services, and all that you will have to do is you connect the connector. It's just like putting an Lego blocks together to build your application. That is it. Choose the right connectors and you get your application running in matter of few minutes. I have not procured anything. I have not spent an paisa till now. All that I am doing is like creating an application, and if you see, here is where I have a number of triggers and templates readily available. I just need not write a single line of code. On click of this, you get the application itself running. In fact, whatever say email yourself tweets about a certain keyword via Outlook. This is just an example. So these are certain templates which can be quick created. Say our requirement was to create a notification whenever the sentimented score for my tweet content is less than a particular value. So I can very easily create it. We were talking about building event-driven applications, right? Whenever an action is being performed by the user, I want my application to react to it. So that is what is defined as a trigger in a Logic app. When I just click on that, all that I will have to do is connect my Twitter account to it. So the learning of the background Twitter API, or how do I establish connection to it, what is open authentication protocol, all these you need not even know. All that you have to know is what is that you want your business application to do. That is it. The services will facilitate you to achieve your any business application needs at ease with the help of predefined connectors. Yes, and this micro billing is one of the key reasons behind the success of serverless computing. You just have to pay for per action. Okay, all that this will definitely reduce the cost. I do not have the upfront cost of procuring a server even when I have not got any customer request. So micro billing is another success of serverless computing. So reduced DevOps, faster time to market, and you get micro billing. So these are why you should choose serverless computing. Now let me help you understand this scenario a bit more with the help of examples. So this is a very familiar example. We day in and day out, we do online shopping, right? So what happens at the background of an online shopping application, an e-commerce application? So I have a website, place an order. So how does my order gets processed? So at this point in time, there will be millions of people who submit orders through Amazon.in. Okay, there are millions of orders that gets delivered every day. How do they seamlessly handle this service? So that is where an architecture requirement of queue comes in. So this is similar to how do we get served in an on like a physical store. Like you stand in a queue, you place the items that you have bought, get it built and carry it and come forward. So the same principle should be followed in an online application as well. So wherein there is a need for an data structure called queue. So in olden days, that is a decade back when I started working into this industry, it wasn't requirement for us to manually build the queue. So we might use arrays in the programming languages that we work with, and we construct them into an queue data structure, and then we start using it. But you believe me, now it is no longer required. You just use the service from Azure or any other serverless service provider, and in like stitch it within your application. That is all. Your custom web application that you write. So certain part would be a legacy business logic which we have to code, right? From the legacy code, from the website, you can push the order into a service bus queue. It's just like first in and first out. I have a queue, I have an order coming in. So now you are decoupling the application. That is my website, which the Amazon.in has nothing to do with the order processing application that takes care of processing the order at the background. So this decoupling will take care of seamless scaling of the application. So all that my website is going to do is pick up the orders and then push it into a service bus queue. So any customer, so the workload on the website has drastically reduced now, and all that it is going to do is it will push the message into the queue and forget about it. And I have a logic app which is going to pick up this order. So as we saw, there is a concept of trigger in a logic app. So I can write a trigger, say when we looked into the creation of this logic app, there were certain triggers that were allowed. So I can also write and trigger means start this logic app when a message is received in the queue. So it is as simple as that. I have not written a single line of code. I have a queue into which my website is pushing the message, and I am going to create a logic app that is going to get started whenever there is a new message coming into my service bus queue. It is as simple as this, that you can start building your application. And if you have any legacy computation that needs to be done, that is not readily available in the logic app, but it is very confidential to your organization on how do we process the order. So the policies of Amazon will differ from policies of Flipkart. Though both are e-commerce applications, they still have certain legacy code that needs to be written. So how does serverless services permit you to bring in such legacy codes? That is through Azure Functions. So Azure Function is still a serverless service. All that you have to do is you can write the piece of business logic, put it into an Azure function, and hit run. That's it. It is publicly accessible. You get an endpoint through which it is globally accessible, and you can inject it into any of your application or to an logic app as well. Yes. So the service bus topic is a similar structure like queue. Only difference is here, every message that gets into a topic can be sent into multiple subscriptions. Say when I need to broadcast an order, say when order has 4 items in it, every item is being shipped by a different vendor. So I will have to send it to the separate vendors for processing. So in such cases, I would use an service bus topic. So these data structures are built to meet the real-time requirements of business. So all that I'm trying to give you here is an gist of how serverless computing can change the way we are building applications. How can you really build real smart applications without much effort, without much worry on the scaling part of it, and not without spending any money or until the application is being actually used. So this is how a complex application can be built. So the beauty here is, say when you build an enterprise standard application, there are certain things that you need to take care of, like security standards. Is it ISO compliant? Is it PCI compliant? Is it HIPAA compliant? So all these are even being taken care of by the service provider. So the part of code that you write, you need to make sure it is following or sticking on to all the security standards. That is all. Rest all infrastructure needs are all being taken care of by the service provider itself. So you can worry less, focus on your business and get your application sooner to market with the help of adapting to serverless computing. So here is another bit more complex scenario I wanted to throw light onto you. Say the Ola cabs or Uber, how much do we use day in and day out? So it not just stops with the cab booking, right? There are trucks, there are fleets that are across the world which are managed by centralized enterprises. So how does a complex scenario like that can be achieved with the help of serverless computing? So in this scenario, they have vehicles running across the world. They are all deployed with telematic devices. So that could be as simple as your smartphone or an chip deployed on the vehicles of this particular company. So what are all the informations that the device can give me is the speed of the vehicle, when is its insurance due, and who is the driver driving it, what is his driving license details, which area is it right now in. So all these such information can be collected by this telematic device deployed on the vehicles across the world. So I need to have an management system which can assimilate information from millions of devices across the world every second. Like this moment, what is its status? What is the speed of the vehicle at this point in time? What is its fuel status? What is the insurance due date of it? So all these telematic information would keep flooding into my actual management system. So this application is expected to digest all these stream of information, process them, and then give me with intelligent information with which I can make decision making. Say on tomorrow, these are 10 vehicles which are due for their insurance. So these were the drivers who were over speeding. So I need to raise a memo for them. So such analytic decisions has to be taken every day in and day out on this fleet management system. Otherwise, do you think it is possible to manage a business that is spread across the world? So that is where intelligent systems need to be put in place. So what is one service from Azure that can help me ingest millions of information from across the world seamlessly? So they have a service called Event Hub, which is capable of ingesting stream of data, and it will capture the information, put it into a storage blob, which can be further processed by my application, which can be on the cloud or on my premise or anywhere. Okay, so that is where this Event Hub can help me. And Event Grid is also another popular serverless service that can connect anything and everything. Like say here, in this scenario, there is an on-premise application. Say the headquarters of this particular industry is located at UK, and they have an legacy application running on their premise in a bespoke server. So they need to connect to this Event Hub and then process this information. So the Event Hub is going to put the information into my storage blob, which is again in a cloud, which is also a serverless service. This application can pick this up and then process. But how will this application know that the data is ready for me to process? So that is where you need to make it event driven. So bring in an event grid in between. So when the Event Hub gets the information and stores it into the blob, it is going to tell the event grid that I have created the blob for the application to process. So this event grid connects my on-premise application with the help of relay, and the application gets a notification that the blob is ready for the application to process. So this is how you connect these services and make them capable of processing real-time information. So in these cases, all that I have to acquire is knowledge on these services. How do I have to rightly make use of them? When should I choose which service? So that is all is required. So with that knowledge, you are now capable of building enterprise standard applications at ease without an overhead of server administration. So these services can be put together. So as you see here, you have bespoke server, which is an on-premise solution, logic apps, API management, service bus and functions, or Your Azure offered serverless computing services. IBM DB2 is completely from a different service provider. So it is possible to integrate on-premise and other service providers. Across service providers, you can build applications. And you can also pick up and use the intelligence of artificial intelligence, of text analytics, computer vision, and face API. So this is how you can put together various services that are available in the serverless computing space, and limits of building applications out of these is really limitless. You can build anything that you want. You see a problem in the real-time business, look out for the right services, put them together, and come up with a real smart application. It is as simple as that. With that, we are coming into the end of this webinar. Thanks a lot for your time. You can stay connected with me through LinkedIn and Twitter, and I'm now open for any questions if you have. Is Talkwalker a digital marketing tool? Yeah, I am actually not a digital marketing expert, but I think it is a social media marketing tool only. Serverless computing is cost-free, or we have to pay monthly as the physical server. So it's not cost-free. When you start using it, you will have to pay. It's a monthly pay cycle, but based on your consumption. Say if your function app just executes twice this month, you get to pay only for those 2 executions. That's all.
Yes, ma'am. We'll send the feedback separately.
Okay.
Yes, we'll collect the feedbacks. And
yeah.
Definitely, I'll send it to you.
Yeah.
So,
Thank you so much.
Yeah. Okay, ma'am. We'll conclude the session. So, on behalf of AJK College of Arts and Science, so I would like to thank our resource person, Mrs. Ezhilarasi, for her wonderful session. I think you made the session very useful for the students regarding exploring a serverless computing. And you made us understand with various examples. You have given various examples, and I think the students might have got somewhat a picture about serverless computing. And once again, I'd like to thank you, ma'am, for taking the time to speak with us today on a very important topic, serverless computing. Thank you, ma'am. Thank you once again.
Thank you so much, and wish you all a great exploration. I hope this crowd is such an obedient set of students. Okay. All the very best.
Yes.
Okay. Thank you.
Okay, ma'am. Okay. Thank you, ma'am. Thank you.